Professional English for AI Invention Disclosures Patent Ready Guide. Welcome! In this micro lesson, you'll craft a crisp, patent-ready disclosure that helps experts grasp your invention fast. Your goal is to tell the complete invention story, what it does, how it works, and why it's new. Use clear, professional English, short sentences, precise terms, and consistent vocabulary. Follow a patent-style structure: problem, solution, system, data, results, and claims. Write so that reviewers understand quickly. Lead with essentials, then add detail. Imagine a busy examiner or CTO. If they can explain your idea after one read, you've nailed it. Start with a real-world pain point in concrete terms. Who struggles today and where? Name the affected users and why solving this matters. Cost, risk, time, or quality. Summarize current solutions and their limits. Accuracy plateaus, slow workflows, high maintenance, or poor scalability. Quantify the impact if unsolved. Misclassification causes 8% revenue leakage, or analysts spend 12 hours weekly on manual triage. Clear problem framing anchors novelty, aligns stakeholders, and sets up measurable success criteria for your solution. State the overall idea in one sentence. We use adaptive contrastive learning to detect anomalies in streaming sensor data. Then map input, right pointing arrow, process, right pointing arrow, output. What comes in, how it's transformed, and the final decision or artifact. Specify model type and key components, encoders, feature stores, retrievers, orchestration, feedback loops. Highlight what's novel or non-obvious. A new loss function, cross-modal alignment, causal features, or on-device adaptation. Explain why prior methods cannot easily replicate this behavior or performance. List data sources and confirm right/consent. Internal logs, public datasets, licensed corpora, synthetic data. Describe pre-processing and features. Normalization, deduplication, labeling, augmentation, and engineered signals. Outline the training setup. Splits, baselines, hyperparameters, hardware, and metrics aligned to business goals. F1. AUC, latency, cost per prediction. Address bias, privacy and security, sampling strategies, fairness checks, PII handling, encryption, access control, and red teaming. These details prove rigor and build trust in your results. Give a high-level map of modules and interfaces: ingestion, processing, model serving, monitoring, and feedback. Name algorithms, models, and tools, vector databases, feature stores, schedulers, and observability stacks. Describe deployment environment and scale: cloud/on-prem, containers, GPUs, CPUs, expected QPS, latency SLOs, and autoscaling. List dependencies and constraints: third-party APIs, schema contracts, data freshness, and cost ceilings. A crisp architecture snapshot shows how components interact safely and reliably in production. Walk through the primary user journey step by step: input submission, validation, inference, explanation, and action. Call out edge cases and failure modes, missing fields, out-of-distribution data, timeouts, or conflicting signals, and how the system degrades gracefully. Show before/after performance, e.g., triage time drops from 4 hours to 18 minutes. Add quantitative benefits: precision +7 points, latency -60%, false alarms -35%, Annual savings $1.2 million. Concrete examples let reviewers envision impact, adoption, and operational fit. State the core inventive step in plain English. What mechanism or configuration delivers the leap? List unique technical advantages. Fewer labels required, stable performance under drift, explainability at token level, or privacy-preserving training. Compare with prior art. Show where existing methods fail, complexity, brittleness, or scaling limits, and why your approach overcomes them. Clarify what to protect first: the training regimen, the coordination protocol, the model architecture interface, or the feedback algorithm. Strong claims focus on mechanisms, not just outcomes. Attach diagrams, logs, and metrics that validate behavior and performance. Define terms and abbreviations so non-domain reviewers stay aligned. Record contributors and dates to establish provenance and inventorship. Provide reproducible steps, environment specs, seed values, config files, and data snapshots. If external materials exist, cite them clearly. A complete package reduces review cycles, accelerates filing decisions, and preserves the technical truth of your invention. Hit send only when another engineer can rebuild your results from your disclosure.